When we look at the sky, our minds fill with stars and planets. How many planets are hidden up there? Thousands? Millions? Or even billions? But before answering these questions, imagine if Earth is no longer habitable and we have to go somewhere else. Where would we go? Have we found a planet like Earth? The answer to these questions is given by a space telescope named Kepler. A telescope that has given us amazing information about the number of planets and other worlds, and shown that there are many worlds similar to Earth. From 2009, NASA's Kepler telescope monitored more than 150,000 stars in a small part of the constellations Cygnus and Lyra. This telescope, with extraordinary precision, recorded the tiniest changes in starlight, meaning when a planet passes in front of its star and dims the light slightly. So far, more than 2,700 confirmed planets have been discovered by Kepler, which make up about half of all known exoplanets. Each of these discoveries has opened a window to a new world, where liquid water might exist, and even conditions for life. Before diving into the details of the discoveries, know that Kepler was NASA's most important mission for hunting exoplanets. This telescope observed more than 150,000 stars simultaneously and detected light reductions as small as 0.01%. Before Kepler, only a few hundred planets were known, and most of them were gas giants like Jupiter. But Kepler found small, rocky planets and showed that Earth-like planets are much more common than we imagined. These discoveries encouraged scientists to more seriously examine the possibility of life elsewhere in the galaxy. Additionally, Kepler's data became the foundation for subsequent missions like TESS, which finds closer planets, and the James Webb telescope, which analyzes planetary atmospheres. Kepler used the transit method to discover a multitude of planets. Imagine a planet like a small ball passing in front of its star. The star's light dims momentarily. Kepler recorded these changes, and if this dimming repeated regularly, it meant a planet was orbiting the star. This method increased the chances of finding small Earth-like planets because it checked hundreds of thousands of stars simultaneously. Every tiny dim could be a sign of a new world. Sometimes several planets passed in sequence, helping to understand the entire system's structure. Ultimately, Kepler found planets in the habitable zone, where the temperature is suitable for liquid water, and this became the basis for searching for extraterrestrial life. Kepler opened up a world full of planetary diversity for us. Rocky, Earth-like planets like Kepler 62f, a world slightly larger than Earth orbiting a cooler star than the Sun, and Kepler 442b, with similar energy from its star as Earth, which might have a rocky surface and even oceans. These are exactly the worlds scientists were looking for. Because before Kepler, most discoveries were gas giants. Additionally, Kepler found super-Earths, worlds larger than Earth but smaller than Neptune, like Kepler 296f, at a suitable distance from a red star with a possible greenhouse atmosphere, and Kepler 440b. These might have rocky surfaces and breathable air. Then, mini-Neptunes like Kepler 296d and Kepler 22b, a planet with the possibility of large oceans in the edge of the habitable zone and thick atmospheres, but perhaps microbial life. And of course, gas giants like Kepler 283c and Kepler 90g, which, in systems with multiple planets, play a protective role, like Jupiter protecting our Earth from stray objects. Kepler 90g is in a system as large as our solar system, with 8 planets, and its gravity keeps the paths of smaller planets stable. This diversity shows that size, chemical composition, distance from the star, and number of planets in each system make each solar system unique. Some have several Earth-likes next to each other, and their orbital dance helps scientists understand how planets form. This harmony increases the chances of life, because stable systems provide better conditions for life. Each of these worlds is like another version of our dream. With every discovery, a bigger picture of the galaxy was built. Kepler showed that the probability of liquid water and atmospheres suitable for life is very high. Now our view has changed. Earth is not alone. Kepler's data helped subsequent missions like TESS and James Webb. For example, James Webb recently examined the atmosphere of planets like K2-18b and reported possible signs of materials like dimethyl sulfide, which might be of biological origin. These discoveries made the hope of finding extraterrestrial life more real. The most important discoveries of Kepler were Earth-like planets. Kepler 186f, the first planet almost the size of Earth in the habitable zone of a red star, with a temperature of about -31 degrees Celsius. But its atmosphere could hold heat like a blanket. This discovery was a turning point because it showed that Earth-like planets are possible. Then, Kepler 452b, known as Earth's twin, a planet slightly larger than Earth orbiting a star similar to the Sun but 1.5 billion years older. Kepler didn't stop there. Kepler 22b with the possibility of large oceans, or Kepler 62f with a possible thick atmosphere. These discoveries showed that there are billions of Earth-like planets. About 50% of Sun-like stars might have a rocky planet in the habitable zone, meaning perhaps around 6 billion Earth-like planets just in the Milky Way galaxy. Kepler opened a door to ask serious questions about extraterrestrial life. We went from question to search, and these discoveries made the future of life search real. Subsequent missions will provide more details on atmospheres, surfaces, and compositions, and perhaps find real signs of life. If one day Earth can no longer be our home, maybe we'll look up to the sky and search for another one. Among all the worlds discovered by the Kepler telescope, a few truly stand out, like Kepler 452b, often called Earth's twin, or Kepler 186f, the first real sign of another Earth. Then there's Kepler 62f. But the truth is, all of these worlds are so far away that even their light takes years to reach us. For now, we can only watch them, dream about them, and imagine what they might look like. Maybe someday, generations after us, with technologies we can't even imagine yet, we'll walk on the soil of one of those distant worlds. Until then, we can only trust our telescopes, and remember that the sky above us is full of unknown destinations.